Hello all, very good morning. Thanks for joining the session. Let me share my screen and then let us start the agenda. Can you please mute? Yeah. So let me share my screen. Fine. So let me take a chance to introduce myself. So my name is Narsi. I have 12 plus years of experience on the various technical stack and then domain. And I'm now working as an associate architect in a product engineering company. And my specializations are the cloud and DevOps, security, microservices, architectures. So these are all the technologies that I teach actually. So identity and access management, Spring Boot, microservices, Spring Cloud, DevOps, so Docker, Kubernetes, right? So all this is the technical stack that I have the extensive experience, and also I love to teach them. So let me explain you about the agenda. Of course, this is a free seminar plus also a workshop that we are conducting, meaning the weekend workshop that we are conducting for the 3 weekends to have the Docker and then Kubernetes extensive, uh, professional level training. So it's a 3 weekend course. So first weekend we'll discuss on the Docker and then the Docker Compose. I'll discuss what is Docker Compose and all. And then second and third weekend we'll spend completely on the Kubernetes. And the duration of the classes will be starts from 10 a.m. to 2 p.m. And then every hour I will give the 10 minutes of the break. And a total of 5 projects we will do here in this Docker and Kubernetes, from Dockerizing to cloud deployment using Jenkins, Ansible, and then EC2. We will deploy through the pipeline. We will deploy the projects. I'll explain 1 or 2 projects to you. With the same fashion, you have to complete the remaining 3 projects. Okay, so first of all, the core agenda is what? The Docker and then Kubernetes, making the application as a containerization and then deploying that containers in the Kubernetes parts. Maybe I'm speaking little higher terminology at this moment for you, but overall you can understand the course is a 3 weekends course we are starting. Today is the seminar and then awareness, how the Docker, why the Docker and all we will discuss, and in real time, how to write the Docker files, what is the standard of it is what we will discuss today. And we're going to start the workshop for the 3 weekends. So Docker and then Kubernetes. Nowadays, it is a de facto tool for the developers. And of course, for the DevOps engineers, it is mandatory. So Docker and Kubernetes is mandatory for the DevOps engineers. Without Docker and Kubernetes, if you will appear for the interviews, you definitely don't get the opportunity. One moment. Sorry, guys. So what we will provide? We will provide the soft copy of the material. We will provide the source code repository, and we will provide the recorded videos. That's what we're gonna give actually. So what are those 5 projects? Let me showcase what are those 5 projects. This is the course objective. Let me open the course objective and showcase the 5 projects. What are those 5 projects? Why required? Why I have taken these 5 projects? Because we might have the DevOps engineers also joining for the session, right? And developers also join for the session, right? So this should be targeted for everyone. Everyone, meaning all the guys can be able to understand and then able to write the Dockerization, Docker containers. So that's the reason taken 3 variety of the projects, meaning 5 variety of the projects. So this is what the projects that we're gonna cover in this one. See this, Dockerizing the static website. So we have a static website, exactly looks like this. So exactly looks like this. So we have a static website. So let us Dockerize this static website. And once after we Dockerize the static website, why I'm stressing here? Why I'm stretching here, Dockerizing the static website? Because we will use Nginx or HTTPD as the web servers here to host the static websites in the production. So interviewers are much interested, like how to configure these Nginx and then HTTPD servers. Guys, am I audible? Can anyone please confirm? Am I audible?
Yes,
Yes,
sir.
yes,
Yes.
Thank you. Yeah, thank you. So Dockerizing the static website. So the static website is built with the CSS, HTML, Bootstrap 4 and all. So what we will do is we will Dockerize it. In order to Dockerize this, it requires a web server. That web server, we will take the HTTPD or maybe the Nginx. Now the interviewers will ask you how, generally they will ask the questions like for the 0 to 2 years or 3 years of experience, guys. So did you ever written the static website hosting Dockerization or the Docker files? Like that they will ask. Because the concept behind, the some web server is required to host this static website. So how do we take that website hosting in the static website in the container is the concept. Another instructor's voice along with me. How that come? Sanket, maybe you joined in two different links. It seems to be at a time. Just check. Right? You might have, doing multitasking. It seems to be. Fine. So the first project we will do is the Dockerizing the static website. So all the applications are there for us. If we can see these are all the applications we have. So this is the static website. And then the next project is the Dockerizing the Node.js application. So why I'm taking this Node.js application? Because the audience now might be joined as the front-end developers maybe. They may be the Node.js developers, meaning the back-end script-based developers, maybe Java developers, right? A variety of the candidates might have been joined to, learn the Dockerization. That's the reason. A very popular nowadays, a commonly used technical stack I have chosen to Dockerize as part of this 3 weekends workshop. So as part of that, Node.js is very popular backend JavaScript-based framework. So Node.js is very popular backend JavaScript-based framework. So most of the applications, like very lightweight applications, or the kind of socket-based applications, are kind of very the high performance applications for the high throughput, high data managing. So Node.js will be used generally. So if that is the case, how you will Dockerize the Node.js application is what we need to understand. Why I'm stressing again here Node.js? Because the static website structure is different. Application is different. Node.js application structure is different. And Angular or the React application structure is different. And Java application structure is different. So various structure, meaning every application or the technical stack implementation have a different structure. Now the complexity or the challenge that we will get is what? How do we Dockerize them? How do we create a Docker container for different technical stack applications? Maybe developers, you don't need to worry about all these things. If you are a Node developer, you just need to know how the Node application can be Dockerized. If you are a Java developer, you just need to know how the Java application can be Dockerized. But if you are a DevOps engineer, you have to know how you can Dockerize any application. How we can do a Dockerization of any application is what we have to know, meaning being a DevOps engineer. That is the reason I'm coming up with this plan. However, the third application is the Dockerizing the React.js application. So you can see the applications with the same this logo and all showing the same, right? Same applications you can see. So if you can see here, the React.js application, this is the React.js application. So same you can see. If I run this application, the same structure you can see, meaning same view you can see. So again, how we can Dockerize it and how to configure the Jenkins pipeline. and how to configure the Docker in Jenkins to build an image. All these things we will see. Our first priority is Dockerizing. The CI/CD pipeline is an optional that again for the DevOps engineers, obviously they will do as part of their day-to-day job. But I'll explain for one project how we can take the Jenkins pipeline, how the Docker will connect to the, how the Jenkins will connect to Docker machine and all. I'll explain through the end-to-end pipeline. I'll explain. So what I mean to say is, in real time, just let me open one more document just to showcase you the the importance of the pipelines and where exactly these auto deployments will be happened. So just let me open this this DevOps content document just to showcase you the diagram. So just it opened in a moment of time. Once it opened, yeah, scroll down. Yes, this is what you can see. This is what. So here is the Docker and then Kubernetes are coming. Here are the Docker and then Kubernetes are coming. Now, being a developer or being a DevOps engineer, right? So first of all, you need to know how to Dockerize the application. In this diagram, the Docker connected to the Artifactory repositories like JFrog or Nexus. That means what? Docker requires the artifact, meaning jar file or war file, right? Docker also connected to Ansible machine to take something from the Ansible machine. That is the Docker file. So Docker file it will take from the Ansible machine. Artifact it will take from the Artifactory. Then using both it will generate the image, push the image to this container registry. Sir, whatever you are talking, we are not understanding. What is registry? What is Docker? Just listen my words. That's it. Terminology, you just listen. Behind the scene, we will discuss in depth while the sessions are going on. But what I would like to explain you is in this throughout the 3 weekends workshop, what you will do. What you will do is we will have all the applications here. We'll have all the applications here, meaning in the Git repository. So auto deployment of the applications will be happened. When you do some changes here, automatically those gets deployed onto our Kubernetes cluster by Dockerizing here. How those will do? You don't need to worry about the Jenkins. You don't need to worry about the Ansible. I'm not going to teach you Jenkins and Ansible. I already have a pipeline setup. I will teach you Docker and then Kubernetes. Then I will connect you guys how it will be in a real-time environment, like CI/CD pipeline will be happened, and then auto deployments will be happened in the Kubernetes cluster. So to that level, I will connect you. Okay, now you can understand being a DevOps engineer or being a developer. If you know this Docker and Kubernetes, because this is the ultimate place where you need to deploy your source code. Your source code is here, and you need to deploy it in the cluster setup using the Kubernetes. And this Kubernetes require the images. That images it will be found from the registry. And to the registry, the images will be created by the Docker and then push here. Sir, what is image? What is registry? What is Docker? Again, I'll explain all these things. But the flow, what you can understand is, source code is here. It will be built by your Maven. You will get our Java, or if it is a Java application, Maven you will use. Source code is here. You will build it here. You will get the jar file or war file. That will be pushed here. That Docker will take the jar file or war file. And Docker also will take the Docker file. By using both Docker file plus jar file, it will generate a Docker image and push to container registry. And from there, the Kubernetes will take. This is the flow. This is the flow, entire flow. Now you need to know how you can Dockerize the image and then push it to registry. And then you need to know how the Kubernetes cluster will go and then fetch the image from the registry and create a Kubernetes pod here. This is the place where you need to know thoroughly. No matter whether you are a developer or you are a DevOps engineer, but this is the place you need to know thoroughly. And for the developers, nowadays, most of the applications are using the cloud native applications. Most of the applications are using the cloud native. Again, what is cloud native and all, I will explain later on time, but most of the applications are simply deploying in the Kubernetes cluster, simple. So in order to deploy the application in the Kubernetes cluster, we require the Docker images. That Docker images we need to create. How to create the Docker images is what we will discuss throughout this 3-weekend session. Perfect. Now let us go here and then again see Dockerizing the React.js application. Then once after we Dockerizing the React.js application, we'll go and then see Dockerizing the Spring Boot application. If you can see this source code, everywhere you have seen one Docker file. See this? This is one Docker file for the React.js application. There is one Docker file for the static website, and there is one Docker file for the Node.js application, and also Spring Boot application. There is one Docker file and microservices. So once the Spring Boot application is Dockerized and then deployed, it will become like this. Then we will deploy the microservices. Okay, so if you can see the microservices also, we have the one Docker file. What do you understand from this entire discussion? When you learn the Docker, you have to be master in writing the Docker files for a variety of technology of the projects. No matter whether the project is the static website or Node.js application or React application or Java application or .NET application or Python application or PHP application, no matter what is the technology is, but you need to write a Docker file here, right? So there is a lot of a beautiful concept behind the Docker, understanding the Docker. Let us understand it in a moment of time. But for now, you just only observe the things what we are discussing about. We are discussing about the applications that we will do in this 3 weekends workshop, number 1. And number 2, we are Dockerizing the variety of the applications. Number 3, for Dockerizing this variety of the applications, we are writing the Docker files for different technology related applications. These 3 points now you need to consider. You just understand. Fine. So you don't know now what is Docker and all, right? So I'm just explaining the course objective, what you will learn. By this way, you might have think about at what level you will get the expertise when you work on different applications Dockerization. So that you will get here. And also the benefit you will get here is the CI/CD pipeline. In a broader picture, how the application will be deployed in the CI/CD pipeline directly in the Kubernetes cluster through the CI/CD pipeline is what you will learn here. That is one of the beautiful thing you can see, meaning global bigger picture of it you can see here. That's what I'm talking about. Okay, fine. So let me go back again. Course content, if we can discuss. Maybe you don't know Docker at this moment, but if I would like to discuss about the course content, maybe you might have seen somewhere, or you might have little knowledge on the Docker, or you are a raw freshers, whoever you are, the target persons. But let me explain you the course content and the benefits of this content. Why I have prepared the content like this, the benefits of it you will understand. Okay, so if you can see this, first we will see the understanding the why Docker, why we need the Docker, we will understand with a use case driven problem statement. Let us see one problem. Let us analyze one problem. What is that problem? So how we can analyze that problem? Just in a moment, I will open the some. Just in a moment, let me open. Just in a moment, let me open the Docker and Kubernetes notes. Just in a moment. What is the problem? I will explain, but I'm just opening the notes which I have written for the other batches. So what is the problem is what we will discuss here. See this, you can see there is a QA setup, there is a dev environment setup, and there is a production setup. So in this QA setup, dev environment, and then production setups, we will see little problems. So what are those problems we will understand here, and how the problem will be solved using the Docker, we will understand. So by this way, you can be very clear, like crystal clear, why we need to use the Docker. Okay, now you got an idea why we need to use the Docker. Then the next thing is what? How can we use the Docker? Why we use the Docker you got now. Then how we use the Docker. So to use it, we have to install the Docker. So let us install the Docker in the Windows machine and also in the Linux machine, meaning AWS cloud I will use throughout our course, and then Ubuntu instances I will use. Let us set up the Docker on the Ubuntu instances and then run the Docker on the Ubuntu instances. So maybe whatever I'm talking may not be visible to you or may not be visualized to you. Just let me log into the my AWS management console to showcase in real time how we will do the Dockerizations and all. So we will prepare one Docker machine, just connect to this pipeline structure. So let me log in here in a moment of time. Let me log in. So just let me log in a moment of time. I can showcase you. I can showcase you. So just let me log in. Yeah. So let me go back to the region, Mumbai region. Just let me go back. What I am explaining, whatever the Docker Kubernetes all we do, that we will do on the AWS cloud, not in your local, because local is okay, but creating the multi architecture is different. Meaning what I would like to tell you is the high availability architecture. You can see here. You can see here, right? So there is a Docker machine. This is the Docker machine, and there's a Jenkins master, and maybe a Jenkins worker. And you can see this. There is a Kubernetes master, Kubernetes workers, and if you can see, there is a what is that? ELK server and Ansible engine, right? So these are all the missions that we will take. But for you, in throughout your course content, you will see the Kubernetes high available architecture and then the Docker mission setup. So just let me quickly start this Docker mission where we have done the setup of the Docker. Please don't meaning to set up the Docker, we required the T2.medium machines, meaning the Docker you can set up on free machines as well, but real applications when you do, you require the more memory. That is the reason we will go for this higher memory machines in the AWS cloud. However, that is not the point I want to discuss now. I'm just starting the Docker server just to let you know how the Docker will be. Just to let you know, let me copy this and then connect to this Docker machine. In a moment of time, I will connect. I believe you don't know what is this Docker machine, how to connect to it. I think you don't know, but don't worry. I'll make you to connect to these machines and then work on it. Meaning installation and all. I will make sure you will be do that. So okay, I was logged in here, right? So let me logged in here. Just let me logged in here. Perfect. Now see this service space, Docker space status. Awesome, Docker is running. What happened here? This is the concept. Starting the Docker as a service and stopping the Docker. Starting the Docker as a service, again, the backend service, and then the service on demand. Both the ways we can start the Docker. So Docker as a daemon we can start, Docker on demand we can start. So Docker as a daemon we should have to set up. So from this, we will understand the Docker architecture. So there is a container D. Keep this in mind. Container D. There is a Docker service. Container D, Docker service. So with this, we will understand the Docker architecture. So that means if you can see the course content. So starting the Docker, setting up the Docker, these are all we will complete in this Docker installation. Meaning you will be able to set up the Docker on your local machine. Plus you will be set up the Docker on the Ubuntu machine. Next, you will understand the Docker architecture. Like what is the Docker client and what is the Docker daemon. So understanding the Docker architecture is very, very important. So this is exactly, you will understand the Docker architecture using this Docker engine. See this started Docker application container engine. Meaning what? Meaning what? And also, if you can see, let me just type Docker space version. You will see Docker engine as a client, Docker engine as a server. Right? You can see two parts are there. Docker engine as a client, Docker engine as a server. So what is this client and what is the server? How the Docker client is communicate with the Docker engine, that is the server component, is what we need to understand. I'm trying to explaining you the course content, what I have designed, how you will learn the the concepts of the Docker is what I'm trying to explain to you. I'm not telling what is Docker, why we use the Docker and all. However, we definitely will go to that state. With the problem statement, we will understand why Docker and then how you will use the Docker. So once the Docker architecture you understand, then we have to familiar with the few Docker commands. For example, I want to see the running Docker containers. So I have used some command. I want to see the images. So I have used one command. Now I want to see the logs of a particular container probably. So I have used this. So meaning the commands are important to understand. So Docker basic commands we will learn here. So if you can see the handout that I have shared here, if you can see the handout that I have shared here, we are pushing the Docker image created here to container registry. So this process is involving with the Docker login, Docker push commands. So we have to first log into this container registry, and then there we need to push the Docker image. So once the Docker image is pushed here, then Kubernetes cluster will take it. So what do you understand from this one? The commands is very important to learn. So what are the commands or we used in our day-to-day life? Those are all the commands I already documented, and thoroughly we will see those documents when commands. And finally, you will see once after the Docker commands done, then you will see how to write the Docker file, and then how to create the Docker images and how to create the Docker containers. So these are all we will see: Docker volumes, Docker compose, and Docker networking as well. So right, so these are all the concepts that we will see. So it is a 3 weekends paid workshop. So 3 weekends paid workshop, and then fee is 3,000. Fee is 3,000 INR, and the recordings will be given to you. The validity of the recordings is 2 months. And source code will be given to you, and then pipeline documents will be given to you, and then the Docker and Kubernetes documents also shared with you, right? So these are the assets that you will get here. So this is the weekend workshop pro forma, weekend workshop details. Now we also have started today some free workshop, right? Just to make you to understand the importance of the Docker, and importance of the Kubernetes. So make sure you will understand the importance of the Docker and Kubernetes. We have started the pre-seminar here. Okay, so now let us understand why Docker. So why Docker? So you might now cleared one thing. Docker is required for the Kubernetes. That is what you understood for now. Docker image is required for the Kubernetes. Of course, in coming up Kubernetes versions, Docker support is removing. But as on today, the Kubernetes version 23 is still depending on the Docker images. But going forward, the Docker images support is deprecating in the Kubernetes. maybe they will give us in an alternate way of loading the Docker images. We don't know, but as on today, whatever the latest version today, that is still supporting the Docker images, right? Fine. So what you will understand now, meaning what you need to understand now, why we need to learn the Docker. Okay, why we need to learn the Docker. So just let me share my screen. I think my screen is lost. First of all, why we need to learn the Docker. That is okay, we will understand, but at what level you need to learn the Docker, right? At what level you need to learn the Docker. For example, let me showcase you one more application here. And let me open this SRC main Java code. I'm just opening some Java code. Maybe few members understand it or maybe not understand, but let me open the Java code. So if you can see this Java code, we are given the database username, database passwords, hard coded here, and then port numbers we given. One moment. Sorry. So here we will understand, how this is what the database, right? Application is connecting to the database. Now, if we can see what we can Dockerize, basically what we have to Dockerize, let us understand now. So we will have usually the UI part, and we will have usually the applications backend part, and we will have the database as well. So these will be always interconnected together. Always they will be connected together. So always these will be connected together, right? Now this connected together is serving as an application. Now, if we can see what you need to Dockerize here, this is the UI application, this is the backend application, and this is the database. So what you need to Dockerize? So we need to Dockerize all of this. We need to Dockerize all of these. So that means you need to containerize all of these. So you need to Dockerize this, and you need to Dockerize this, and also you need to Dockerize this. These three things you need to Dockerize. So that is the reason in the course content you have seen how to Dockerize the UI application, how to Dockerize the backend applications, how to Dockerize the, of course, while the backend application is Dockerizing, we also Dockerize the database. This is fine. Dockerization we will do, meaning you are learning the Docker here. So using that concept, you will Dockerize it. Of course, why you need to Dockerize? What is the need of Dockerizing it? We will discuss in a moment of time. But you just understand, you will Dockerize these components. Now, after Dockerizing, how these components will communicate each other, right? This container, how it will be communicating each other. This Docker container, and this Docker container, this one, how they will be communicate each other is again a bigger challenge for us. Okay, so for that we will use the Docker networking concepts. There are various concepts you will learn. The data management purpose, the Docker volumes concept is there, and then the various applications communication perspective, Docker networking is there. So you will learn a lot of concepts which are required in the real time. But however, why we need to learn the Docker? So that is what we're going to see now, which is very important point now. Yeah, there is an application UI, backend, and then database. That is fun, but why I need to Dockerize it? Exactly. Now let us see. So in real time, we will have always the environments like this is the development environment, right? So we always will be the various environments, development environments, assume. And similarly, we also will have the testers environment that we are calling as a QA environment, isn't it? So QA environment. And similarly, we have the production environment, like how your Facebook, Google are you are accessing right now. So that is what the production environment, where the customers can directly access this. So production environment. Assume there is a no Docker. Assume there is no Docker. No Docker is there. Assume there is no Docker. Now, what is the problem we are now trying to understand? Assume there is no Docker. We have the 3 environments. So developer always will work here. So developer always will work in this dev environment. Developers will always work with the dev environments, right? Because whatever the code they developed, whatever the code they have written, that code they will test in their development environment. Then where the testers will test. So he's the backend developer guy. So who will develop the things and then test it with the development environment. Fine, whatever the code he written, it will be moved to this development environment. But how the testers will test? So testers will test the application once the code moved to this QA environment. And once the QA is tested thoroughly, the same will be moved to the production. So this is how the application build will be released to the productions. So this developer will write all the source code and then will be deployed on this development environment. These guys will do the unit testing, integration testing, and then for the functional testing, we will use the QA team where we have a dedicated QA environment. Now, whatever the code is there, that code need to move to this QA environment. And once the QA is done their testing, the same code again need to move to the production environment, isn't it? For example, this is the Java code. So what I have to Java application, assume what I have to do here in this machine, in the development machine, I have to install the Java 11. Assume Java 11 I'm using. And also I'm using here the React application. So I have to install the Node.js as well. For example, Node.js 16, I will install. 14 I will install, just in case. Node.js 14 I will install. Why I'm mentioning the versions, you will understand in a moment of time. Now I have the Java installed here, Node.js installed here. Then what I will do, I have my Java code. I have my code, right? Code files. So whatever the Java code I have, maybe the source code I have here. Here is my source code, right? This source code is written by whom? Written by the developers. Now this source code, what I did, this source code I build as a jar or var. I build it as a artifact. I build it as a artifact. So here is the Java. So I build it as a jar or var. And I have the server. This is the server. So which is nothing but the Tomcat. So here is the server. Now what I did, the code files, whatever I build as a var, assume I deployed in this Tomcat. So this is the Tomcat server. Tomcat 9 it is, 9.x. Perfect. And also here is the Node.js, whatever the front-end files, the front-end files also I deployed here. And similarly, we also want the database. So assume MySQL we are using. So MySQL database, I have done the setup here. So assume MySQL 5.8 I'm using. So MySQL 5.8 I'm using. Perfect. So this is what the technical stack that we have on the dev mission. Assume what we done. We have installed the Java. We have installed the Node.js. We have installed the MySQL. We have installed the Tomcat. So I will just note it down. So because just to connect you guys to understand what is happening. So on the dev machine, what we done? On the dev machine, number 1, we installed the Java. Number 2, we installed the Tomcat. Number 3, we installed the Node.js. Number 4, we installed the Java, Tomcat, Node.js, and also we installed the MySQL, installed the database. And then what we did, we deployed the Java application in Tomcat. And what we did, we deployed the UI application in Node.js, right? This is what that steps we performed in this dev environment. So now dev is completed. We have completed the dev and all. Now it's time to set up the QA machine. Again, what we need to do? Again, we need to install the Java here. Again, we need to, Again, we need to install the Java here, right? Again, we need to install the Node.js here. Like whatever the Node.js version we have, exactly the same version we have to install here, exactly the same version. And we have to install the MySQL here. And we have to install the Tomcat also here. And then we have to copy the files, build files here. And we have to copy the UI files also here. And then we have to deploy these files into the container, right? Again, once after all this setup is done, then the testers will start the testing. So testers will start the testing. So they will give they will do a thorough testing of our application. They will give the test results to us, right? Fine. Now we have done this one. In the production is little slower environment. So it is not using the, of course, Java 11 is using here. So on production machine, I will use Java 11. And Node.js 14 we are using, but here the Node.js 12 is only using. Here is Node.js 12 is only using, just assume for a while. And MySQL 5.8 not we are using in the production, assume MySQL 5.6 we are using. And assume Tomcat is what we need to set up here as a 9.x. And the Java code we moved here, and then the UI code is what we moved here. And then we deployed these codes in the respective servers. Now here we have the two problems. Problem number one. Two problems, I think you already have observed the problem. So what is the problem here? Problem number one. Problem number one. On every machine, we have to keep on install the same set of softwares repeatedly. Repeat one more time. On every machine, I'll repeat one more time. On every machine, we have to install software stack again and again. When a new deployment or when a new machine will come up, again we need to manually install it. So meaning the code, whatever in the dev environment, in order to move to the QA environment, right, the infrastructure also we have to set up as that of the dev environment inside our QA environment, right? So here we have done some setup manually, and the same manually also we have to do the setup here. This setup taken the 2 days. Again, QA also might take 2 to 3 days of time, right? Two things you have to observe here. Number one, same set of softwares we will need to install all the environments. Number one, if there is no Docker, I'm talking about. Number two, the versions, whatever the versions were used by the developers in developing the application code, the same version we have to install in all the down the line machines where we are testing or where we are using, the customers are using, right? This is the second thing. Third thing is what, assume by chance, if your production servers are legacy, by chance, if your production servers are legacy, then if you want to upgrade or downgrade your environments, then what you have to do? For example, Java 11 is using, but Node.js 12 is using in the production. So we have to downgrade it to Node.js 12. So downgrade everywhere. Whenever the downgrade or upgrade is happening, you need to manually upgrade or downgrade everywhere, which is a complex process. Now, overall, this process, what you are understanding, only one point. The code, when we are shipping from one environment to another environment, we also shipping the infrastructure required to run that source code. Right? So only one point. So the code when shipping from one environment to another environment, we are also shipping, we are also not shipping. The code when we are shipping from one environment to another environment, we are also have to make sure the infrastructure was already there on the target environment. So the code when we are shipping from one source environment to another target environment, we also have to make sure the infrastructure was already there on the target environment. So what is the infrastructure? The same Java, Node.js, MySQL, Tomcat. So all we have to keep here. Then we can move the files from here to here. Okay, so this is the first problem we can see. The infrastructure we need to set up on the machines manually or priorly we have to set up. Then number 2, when we are shipping the code, assume the development environment machine is the Windows machine, assume. And the QA environment machine is the Linux machine, assume. Production is the Linux machine. So when the two different or when the different operating systems of the machines were there, or the environment is of the different operating systems, then running the code on one operating system may or may not run exactly on the another operating system because of some directory dependencies, permissions management probably. Assume here you have a file uploading logic. So this is your Windows machine. So usually what you will choose a directory as, usually you might use any of your local directory to dump the files temporarily and then you will put into the database. But at least some temporary location you need to dump. For example, videos. So this is the drive where you will dump the videos. But the same D drive, so same code, when you move to QA and when you uploading the video uploading functionality might not work because QA machine don't have the directory structure like CRD. So QA have the directory structure like OPT/OPT or maybe some other directory structure it have. Right? So what do you understand now? Due to the various operating systems file structure, directory structures, our application also works in one environment, may or may not works in the another environment, which is of two different operating systems, two variety of the operating systems. So dev is Windows, assume everything worked well, but when moved to QA, it didn't work because QA is a Linux machine. And when we moved this QA to production, it is also Linux machine. Here also we have the directory structure called OPT. So, but we are in our code, we are uploading the videos to D drive, but there is no D drive here. So the functionality related to upload video is not work here. Then QA people will do what? They will raise an issue saying that, upload video is not working in QA. They will raise an issue saying upload video is not working in QA. But developer will argue with them. No, upload video is working fine in my machine. Even the developer will showcase the demo, like upload video is working fine in his machine. But the same to same code, when we move to QA machine, maybe the upload video is not working. Why? Because of the different operating systems, because of the directory structure is different, and we forgot to change the directory structure from D/videos to OPT/videos. We forgot to do this. As we forgot to do this, this is a manual error. right? I just forgot to do this, which caused this error, like working in dev, not working in QA or production. So these are the problems that we have in real time. In real time, when we are moving the code from one environment to another environment, these are the problems we have. So how to solve these problems? How to solve these problems? Now carefully observe, please. In dev environment, what we will do is let us install the Docker. Just let us install the Docker. So I'm just typing the Docker here. In dev environment, just let us install the Docker. I think I'm audible to you, right? Yeah. So let us install the Docker. Yes. So in dev environment, let us install the Docker. So this is the Docker. Here is the Docker. So just install the Docker. Okay. Now what we need to do? We need to create an image for the same to same. How the Docker is solving the problem, I'm just explaining to you. So here what we will do is let us create one image using the Docker. Let us create the image, Docker image. So just I'll take one simple screenshot to make it more effective. So let me take one simple screenshot to make it more effective. Just an image. Yeah, otherwise I can take just to make it more effective. Let me take it as an image. Yes. So this is the Docker image. So what I will do is I will build one Docker image. What I will do here in this Docker image, I'll keep Tomcat. I'll keep Tomcat in this Docker image. I'll keep Tomcat. Then what I will do, I'll keep the MySQL inside this image. I'll keep the MySQL. Then what I will do, I'll keep the Java here inside this image. I'll keep the Java inside this image. And what I will do, I'll copy the source code in this image. Of course, UI source code and then backend source code. Now what you can understand, everything is inside one image. Everything is inside one image. This is the term. Right? Now what I will do, when I would like to ship this entire application to another environment, like QA environment, what I will do is I'll just give this Docker image to this QA environment. Now same to same Docker image will be shipped to this QA environment. So, but what I will do before that, I will install the Docker here, and whatever the the Docker image is here, I will same to same the same Docker image. I'll copy from here to here. That's it. Did I install any software here explicitly? No, I installed only Docker. Now, when I copied the image, I can run the image as an application here, which is calling as a container. What I did, just I have transferred the image from here to here. That's it. Here we have not installed anything. So again, if you want to move to production environment, then what we can do? Simply, we again can move the same Docker image from here to our production environment. Same Docker image with all these things. So we can move everything to the here. Sorry. So same to same Docker image, we can move from here to our production. What I mean to say is, whatever the Docker image here we have tested, right? The same Docker image will be moved to this production. Same Docker image. So no need to again install anything, and no need to worry about the versionings. No need to worry about the versionings. No need to worry about the installing them. The only thing is what we need to install the Docker here. Everything. So Java, everything. So Java, and then MySQL, and then the source code. Everything are taken from here to here. So it is not copying, but you just understand from here to here, everything is copied here. So the problem of this issue is resolved. One problem is resolved. What is one problem? Copying the code from this machine to this machine required to set up the infrastructure on the QA machine as well. Again, copying the code from QA machine to production required to set up the entire infrastructure on the production machine. One moment. Sorry guys, maybe you might had some disturbances because of some construction work is going here. However, so from the QA machine to production, when you are copying the source code, you need to copy the entire technical stack here, infrastructure here, meaning you need to set up the infrastructure here. That is a problem. But with the Docker, how it is resolved? We are creating one image. Image is containing all the technical stack here. No need to install anything on the downline machines. Just we need to run the image here. That's it. So just we need to copy the image from here to here, and then make sure the image is runnable by the Docker. So this will solve the problem of the infrastructure maintenance among the various environments. Problem number 1 is solved. Now problem number 2, how we can upgrade or downgrade the versions of the, that's what I'm now talking about. So how we can downgrade or upgrade the versions of the image or the technical stacks in the image. For example, here we have to use a different version of the software. What we can do is, images are unmutable. Once the image is prepared, we cannot change it. Once the image is prepared, we cannot change it, right? So, but for the version upgrades, version downgrades, for the better management of these images, right? Meaning the high availability of these containers, and then version upgradings, version downgradings, scalability. For all these things, what we will do? We will use the Kubernetes. We will use the Kubernetes. So using Kubernetes, what we can do? We can upgrade a particular version. We can downgrade to a particular version of the software inside the image. Meaning software inside the container, we can upgrade or downgrade. So for example, I want a different software here. No matter, I can run this image, and then once the container is created, I can upgrade or downgrade that using the Kubernetes. Using the Kubernetes, I can upgrade or downgrade the versions. I can supply the versions. So using Kubernetes, I can do that. So that is the reason we are using the Kubernetes and then Docker for the better management of the applications in production. So here we can use the Kubernetes to upgrade or downgrade the versions of a container, versions of the softwares that are running inside the container. The container is created by using the Docker image. Not only this, for example, I want 3 more copies of this Docker image as running as a application. So this is the Docker image. This Docker image is running as an application. Just assume. So assume it is running as an application. So I want 3-4 instances of the application. How do I do that? That scalability we can achieve using the Kubernetes. So for example, this is the application. So this application is running using this image. Similarly, we may have another application here. I want another application here. How do we create many applications, many instances of the applications? Managing through a load balancer, assume, right? So first of all, scaling of the applications, scaling of the Docker containers are possible using the Kubernetes. So to maintain the many instances of the application, we are using the Kubernetes, because if any application will down, the other application will start serving the data. So zero downtime of the application can be achieved using the Kubernetes. So whatever the Docker containers created, those Docker containers are managing by this Kubernetes, like zero downtime and scalability, what is that? Fallbacking, all these things we can achieve. For this, we are using the Kubernetes. I think you got now, right? What is Docker, how it solves the problems and all. Any questions for me? Any questions?
Sir, I have a couple of questions.
Yeah.
So first thing is, in dev environment, the infrastructure is there. So the code is also there along with it?
Exactly, yes.
So tomorrow, let's say there is some change in the UI code, or let's say there is change in the backend code. So how is it going to be managed? Like JFrog Artifactory, it will be generating the WAR file and it will be sending it to the Docker, right?
Correct.
So once it sends it, so what's the flow from there? And can you connect that system to this system? Yeah.
Exactly. So once it, Artifactory will get the new jar file, the new source code. This Docker, again, we have to build the new Docker image with the new changes. Sorry, guys, lot of noise is coming, but new Docker image we have to prepare with the new jar file is coming here, updated jar file. The Docker images once created are not changeable, they are immutable. That means what? Assume I have done some code change here. Jar is updated here. New jar came to me. With that new jar, I have to create one new more Docker image and then push it to here. So maybe the Docker image version is 2.0 or 3.0, like that. So Docker images versioning we will do, and then the source code changes can be tracked with the various Docker images of different versions. Got my point, right?
Yes, sir.
Yes, sir. Okay, sir. If anything, if we change anything, even a single thing in that image, we need to build a new image, right?
Exactly, because images are unmutable. Images are immutable. We have to do that.
Okay, it's one or nothing.
Yeah.
Every time we can, for example.
Not every time. When the source code, when you build the source code, then only you have to regenerate the Docker image. Usually we are now building the cloud native applications, right? What is the cloud native applications are talking about? Build only once, deploy it many times, build only once. So if that is the case, any questions?
Yes, sir. In a dev environment, every day I change the code, and every day I change the documents.
Correct. Every time when you change the code, every time Docker image will be prepared for sure. Yes. Should have to.
What is the? Okay.
But you remember one thing. Your code changes directly. You won't push it to the release branch, na? We are maintaining the.
Yes, sir.
We are maintaining the branches. So you will do your changes to your branch only. But once your changes merged with the release branch, then only the Docker image will be created. Got it?
Oh, got it.
Yeah.
Sir, are we going to create an image using front-end, back-end application as single image, or we will do it in different images?
Different images. So front-end have one image, back-end have one image, database is having another image. So the three different images we will create, three different containers we will create, and we will get one challenge, like how to make the communication among these containers is the challenge we will get. We will solve that challenge using the Docker networking. Okay.
Got it, sir. Thank you.
Yeah. Someone have asked me the question, if all these things are doing by the Docker, like Kubernetes require the Docker, why the Kubernetes is deprecating the Docker in its coming versions? Maybe Kubernetes is writing the similar container technology like the Docker. We don't know why. Kubernetes is the Google guys one. Maybe Google also might have the container technology with them. So that might be the reason. A new container technology they will come up, like how the Docker is working. Maybe the similar function also that will come up. So maybe in the coming 24th version onwards, they said they will be deprecated. Not now, right? So Kubernetes and AWS support auto scaling and cannot by Spring Boot. Hey, Spring Boot is an application. We cannot auto scale the Spring Boot applications, right? Meaning scaling is what here, maintaining the equal set of application instances is nothing but the scaling. Maintaining the equal set of application instances. Here I have used word called equal set. Meaning what? If one will down, other will come in place. That is called what? The fallbacking. If one will down, other will come. Equal set should have to be maintained here. Who will do this? Kubernetes will do this. So Spring Boot is just an application. The application will be scaled using Kubernetes as an equal set. Got it? So what about security for server to server connection? Security is different. Security will be maintaining at the application level, and security we will maintain at the Kubernetes level. Container level security is not there so far. So using this container Docker containers, we will create the Kubernetes pods. So again, pod level security is there. So that is what we have a concept called RBAC implementation in our Kubernetes. So you can see it in our Kubernetes course content. So I don't have the time to explain you probably, but you can see the security here, access control. So how the security being maintaining among the various pods. Every pod contains one Docker container. Every Docker container contains one application. So how the security will be maintained for the application running here is being taken care by the Kubernetes. Any questions? Yeah. So if MySQL tool is dependent, then we definitely should create new image from Win to Linux environment. No. I think it is misunderstood. So here, if you can see, MySQL is the server. So I can showcase you the code. Maybe you are asking the questions, meaning you might have been already familiar with this one. So let me showcase you the code, like how we will do the Dockerization for our. So just let me go here. DevOps. Just let me go here. DevOps with it. This is the latest code. Applications. And here, if you can see how you will write the Docker file. So open this. Right. So this is the Docker file that we will write. What it is containing, basically Docker file is containing our var file. We are moving to the Docker image work directory. I'll explain all these things when the situation comes. But what is this var file contains? Again, that we need to see. So what is the var file contains is, if you can see our application.yaml file, just in case, let me open with the STS, or else let me open with the, if it is STS, then you can easily see. That's what. So what I mean to say is, just let me open with this Notepad++. Now see, this is what I would like to showcase you. Developers, please remember how you can Dockerize. It is not, see my code, how I have Dockerized. I have used some syntax. Maybe among you developers are also there, right? See how I have used this parameterized approach I have taken. And you can see here, our application is connecting to the database, database container. So this database container, we will supply from our Docker compose file. If you can see here, so here we will supply the database. See this? This is what the database service. This is what the application service. Now the container name, what I have given, Shopify Me, Cloud DB. This is the network. See what I have given. I have given the container name. This is actually RDS I have used. When RDS used, I have given the RDS name, but when RDS is not used, we have to give the service name. This one, Medilab Monolithic App DB service is what we will give here. What do you understand now? Container to container linkage is required to be happened, right? Container to container linkage need to be happened. So that linkage we will do using the Docker Compose files. That is how the Docker Compose is said to be orchestration of the Docker containers. Docker Compose is a tool to orchestrate the Docker containers, meaning this is one Docker container, this is one Docker container. It is managing the linkage between these two Docker containers. And we have used here, see, volumes concept, used here the network concept, lot of concepts we have used actually. Make sense? I hope I addressed your question. Right. So this is a 3 weekends batch, and then the fee is 3,000. I already have told you, right?
Sir, how many hours per day?
10 a.m. to 2 p.m. let us spend. So mostly every weekend, 8 hours we'll spend. So okay. 3 weekends, maybe it will be also go to 4th weekend as well, based on our, because you might ask various questions. I have to spend some time there. Maybe 3 to 4 weekends it definitely can take, but in depth you will learn. So what is the in depth you will learn is, you can see this Kubernetes course content. You might have already know Kubernetes course content. You can find it from the DURGASOFT websites. So in depth about the Kubernetes, we will learn. We will spend almost all our time in the Kubernetes only, not on Docker. Docker will spend just 1 week or 1.5 week, but 2.5 weeks, if possible 3 weeks also. Let us spend on the Kubernetes. That much of importance it is having.
Yes, sir. And last question. In all cloud, they have their own version of Kubernetes.
Exactly.
AWS.
Exactly.
And also Redshift, OpenShift Kubernetes is also there. Can you also please give some brief intro about OpenShift?
Exactly. So, okay, first let me come from all these tags. So AWS have the EKS, Elastic Kubernetes Service. Azure have the AKS, Azure Kubernetes Service, and Google Cloud have the GKS, right? And then OpenShift also have the Kubernetes container support. So what are all these doing basically? They are using the concept called Kubernetes in a managed way. In a managed way. That means in order to install the Kubernetes, one moment guys. Sorry. So in order to install the Kubernetes, we need to make sure the certain standards like, master mission, worker missions, KubeADM tool, network setup, and exposing the volumes considerations. All these things we need to manage ourselves. So there were already the hosted solutions who are already managing. So such already available hosted solutions we have, we can go for them. So why we are not go for them is, if we go for them, you don't know behind the knowledge of the Kubernetes. What is Kubernetes? How Kubernetes will work? Maybe you don't know. So that is the reason we are going for the Kubernetes learning here with the manual installation of high availability architecture. Then exactly the similar fashion, the clouds will maintain the same. You got it right? And OpenShift is little different. It also using the Kubernetes. It's already have the object management called Keystone. Early in the year 2014, it have the object store called Keystone. So that object store called Keystone has been leveraged in such a way, whatever the objects that we are uploading or then want to maintain, it is maintaining in this object storage. So like how your EBS in the AWS, OpenShift also have the keystone. So OpenShift also have the support for this Kubernetes, so that which will use the volumes underlying is as a keystone. So this entire managed instance we will get if we use this OpenShift as a suite. Okay, so volumes plus the Kubernetes architecture, master slave architecture, high availability, single node, all these things we will get as a one single suite managing by the OpenShift. So again, so we have to do what? We have to install ourselves and then understand the Kubernetes first. Then we can easily understand the other cloud provided solutions. Got it? I addressed your question, right?
Yes, sir. Yes, sir. Thank you very much.
Yeah.
Sir, you'll be teaching YAML files, sir.
Exactly. YAMLs only we will write. We can see Docker compose.yaml file.
So
We will
you'll be
write
teaching
YAML.
us, right, sir?
Yes. I will be teaching how we will write and all. If we can go to the Kubernetes, these many Kubernetes we will create. For example, if we can see Kubernetes, for the application we will write 5 YAML files, and then for the database we will write 7 YAML files. A total 12 YAML files we will write. So I will explain how to write these YAML files, the syntax of it, and all I will explain.
So
Class and
fundamentals. Yeah.
Yes, from the beginning we'll see. So class will be on Saturday and then Sunday. Both class will be on Saturday and then Sunday. Let us start the session from 10 a.m. to 2 p.m. on Saturday, and Sunday it's up to you, 9 a.m. or 8 a.m. Let us plan for it on the coming days. That is up to you, meaning based on our compatibility. Tomorrow. So tomorrow once you done your payments today and registered, tomorrow we have the class from 9 a.m. So let us connect tomorrow from 9 a.m. to 1 p.m. and then start our Docker. What is Docker? What is and all we will discuss. Okay.
So
Any questions?
this monitoring solutions also running, right?
Monitoring is different actually, meaning we are not, of course, once you know the Docker, setting up the monitoring tools also, it is not matter. But why the monitoring tools are required here? Not required. We are not building the complete pipeline. So of course, I got your point. We are deploying in the Kubernetes architecture. Then how do we manage the logs of it? How do we manage the performance metrics? How do we monitor the application running inside the Kubernetes is what your question, correct? So yes. For monitoring, Grafana, Prometheus, ELK, and EFK, a different technical stack is there, but that is I'm not covering here because time doesn't sufficient for us. But if you want the documents, I will give you the documents for the Grafana and then Prometheus. Anything else, folks?
Sir, will this course be useful for CKA certification?
Yeah, certification, honestly speaking, Kubernetes, whatever the concept I have written here is the certification concept only. So whatever the concept I have written here, content I have drafted here, this is up to the Kubernetes administrator certification level. But Kubernetes administration certification is a written exam. It is not like object oriented or object based one, meaning multiple choice not. It is a written exam. So if you really thorough with this content, you will be able to write the certification as well. Okay, so but it is a written examination. We have to be very, very in depth. We have to see, we have to practice, we have to learn. You will give the use case, we have to write the files for that. Okay, but the content I have drafted here is 100% Kubernetes administration certification content. Fine.
Okay, sir. Thank you.
Yeah. So
I have a question. We have this Kubernetes architectures only on the production environments, but wherein on the lower environments like dev and QA environments, we usually prefer taking the Docker images. And do we have to replicate those Docker images on different machines in order to support scaling for our applications? That is how a manual approach we follow on lower environments, and for scaling like using Kubernetes, we can do it on production environment.
So basically, the ideal way is every environment should be installed with the Kubernetes. That is the first thing. though it is dev, though it is prod, though it is QA, everywhere we have to mention, everywhere we have to install the Kubernetes. Assume developers are there. You are a developer, I'm a developer. First of all, I have to test everything in the Kubernetes, whatever I have written. For that, I have a mini cube, which I can set up in my local. Okay. Similarly, in dev environment, we can set up the mini cube, single node cluster. But in QA, we can set up the multi-node cluster using Kubernetes. What I mean to say is Kubernetes must and should be there everywhere, which will uses the Docker images to run the Docker containers inside the Kubernetes pods. But Kubernetes should be there everywhere if the Kubernetes is the deployment environment. Got it? Okay. I'll tell you why we need to have the Kubernetes. I will tell you. So just to see this file structure, database structure, there is a configurations map, config secrets, first instance volume claim, namespaces, finally deployment, and then service. In deployment, let me open this file. Just the Docker image, whatever we have built, right? That Docker image just we are using here. That's it. Or else our application, if you can see, this is our application. So our application build image we are using here. That's it. So this is creating the container. But on top of the container, we are doing a lot of things here. What we are doing on top of the container, we are maintaining the namespaces, we are maintaining the configuration maps, config secrets, volumes, lot of we are doing here to better management of the containers. So that is the reason, just by testing the container, we cannot assume that it will be work as expected inside the Kubernetes cluster. No, there is no guarantee for that. So that is the reason, though the Docker image has been created, we need to test it inside the Kubernetes environment, no matter where it is, dev or QA or prod. Got it? Yes, yes.
Sir, are we going to see the CI/CD workflow?
Yes, yes. CI/CD pipeline. First, what we will do is weekend 1, we will complete the Docker. Weekend 2, weekend 3, we will complete the Kubernetes. Once Docker and Kubernetes is completed, then what we will do is we will start our CI/CD pipeline. So how the CI/CD pipeline will be, just a glance I will show you. Just my login to my GitHub. Just in a moment I can show you. We already have the setup. I will let you know. You also can do how you can do. So morning DevOps 1. So go here. Go here. This is the deployment. This is the deployment. See this? We already have the dev applications, dev database, Kubernetes files here. So if you can see these settings, this is being hooked with the Jenkins. So webhooks, see this? It is pushing the changes to the Jenkins. Now Jenkins taken up, and then Jenkins will follow this pipeline. So this pipeline is already there. I don't explain this pipeline to you, but whatever the Docker and Kubernetes that you have learned here, right? Those files we will deploy through the already existing pipeline. Okay, but of course I will explain you how the files are sharing, how the connectivity is happening among the various tools. I will explain, but in depth of this pipeline, I don't explain, because the concept is not pipeline. Concept is Docker and then Kubernetes. But once after you done your Kubernetes resource files creation, like how I have created, right? Develop for the dev, I have created the Kubernetes files. For the database, I have created the Kubernetes files. Once you written these database files, I'll make sure your database files or your Kubernetes files will be deployed through the CI/CD pipeline. That is the agenda. So last weekend, we will set up this CI/CD pipeline.
So will you share that script for us, sir? That CI/CD pipeline script, so that
yes, I will share. So however, we gonna use the Jenkins size pipeline concept only. So this file I will share with you, so that you can use this file as is, just to change the machine names and all. That's it. Maybe wherever required the IP addresses you can change, and I will let you know how to do and all. Anything else, fine? Anything else, or everything is okay? Fine. Okay, folks. So go and do register if you are really interesting. So let us learn at the master level, not the beginner level, not professional level. Let us learn the Kubernetes at the master level. Okay. So 3 weekends, maybe 3 to 4 weekends also you have to consider. 3 weekends maximum, I'll try to patch it up. But if not, you also have to stretchable to extend 1 more weekend as well, because we're going to discuss in depth. No concept will be left out. Everything will be explained to you. Everything will be written from the scratch in front of you. You also practice along with me, because you will get exactly 5 days of time again to come back to the next class. Okay, so grab this opportunity and then start your registrations if you are really interested. If nothing is there.
This session we little logged in later. Can we get a demo session like an ready like any recording session? We'll get it. This one.
Yeah. This recording will be given actually. May probably upload it to YouTube, I believe. And whoever now registered, right, logged in here, right? Yeah. Those are all, we have the email IDs of all those things, all those guys. So for all those folks, the email will be sent with the recording videos.
Okay, sir, definitely.
Okay, folks, I'm stopping my screen share and then leaving for the day. If you are interested, go and then do your registrations. Let us start the session tomorrow from 9 a.m. to 1 p.m. Thank you so much. Docker, let us start tomorrow. Thank you.
Thank you.